Today we're going to do a major linear equation review. We're going to hit a little bit of everything that hopefully you talked about back in Algebra 1, 2. So first question, I guess, is what makes an equation linear? An equation is linear if the line that it creates, if we're going to graph it, would be, well, a straight line. I guess straight in line would be repetitive. It would create a line. Thus the word linear. And now when we talk about linear equations, there's a lot of different forms. If you remember back when you first started talking about graphing and things like that. And that's what we're going to try and capture today. We're going to try and hit a little bit of everything today. Okay, so let's first talk about something that's called standard form. Standard form looks like this. AX plus BY equals C. Okay, where there are certain rules that we're going to follow, where A, B, and C, okay, all have to be at least integers. Okay, but actually, what we're going to do is we're actually going to say that A has to be a whole number. So in other words, there's no fractions, no decimals, and A has to be positive. Essentially, is what we're saying right there. Okay, it's not gonna be a it's not gonna be 0. Okay, but it has to be a positive. Okay, so let's talk about like something like this. Now this is not in standard form. So how do I change that to standard form? Well, what I would do first is I would probably move the x to the other side, and just so we can rewrite it. So if I subtract 1/3 over, I'd get negative 1/3 x minus 2y equals 1/5. So I have it kind of in the right order, x, y, and then my constant. But the problem is two things. One is the x is negative. That's bad. We don't want x to be negative. And then also we have fractions. We got to get rid of those too. So what are we going to do? Well, to kill kind of two birds with one stone, what I'm going to do is I'm going to multiply everything by negative 15. Now, how did I come up with negative 15? Well, as I look at this, I see I have a 3 here and a 5 here. Okay, the least common denominator between 3 and 5 is 15. And then also, if I notice that this is a negative, to get rid of that, I'll just multiply by another negative. So that's how I came up with negative 15. So when I do that, and I distribute, I get 5x plus 30y equals, here I get negative 3. Okay, so there you go. Everything is lined up where A, B, and C are integers, and A is actually a whole number, so it's positive. Okay, so that's how you change things to standard form. So let's go through. I got a whole list here of stuff that hopefully is review. Slope-intercept form. This is the one you probably know really well. That's y equals mx plus b. Remember where m is your slope, b is your y-intercept. Point-slope form. Y minus y1 equals m times x minus x1, where m again is your slope and x1 or y1 is a point that you would use. Slope formula is y2 minus y1 over x2 minus x1. Okay, you subtract your y's, subtract your x's. Remember the y's are up on top because the y's are like the rise, if you remember the phrase rise over run. To find the x-intercept. To find any x-intercept of a graph, or using the equation, is you plug 0 in for y, solve for x. And the opposite is true for the y-intercept. Plug 0 in for x, solve for y. Okay, so that's a big review. All these things, hopefully, that you have already talked about. So let's move on down. Let's talk about an example or two I have here. Okay, so first thing I'm going to ask you to do is change the standard form, if possible, that is, and then find the x and y-intercept. Okay, so as I look at this one right here, I would subtract 14x to the other side. So I get negative 14x plus 2y equals negative 10. It's not in standard form yet because this is negative. We want that to be a positive. So I'm going to multiply both sides by a negative 1. And so I get 14x minus 2y equals 10. So now it's in standard form. And the nice thing about standard form is it makes it very easy to find x and y intercepts. The x-intercept, if you plug in 0 for y, so that essentially cancels that out, we get 14x equals 10. Divide by 14, so x would equal 10 14ths, which to reduce it would be 5/7. The y-intercept, plug in 0 for x, which essentially would cancel that out, and you get negative 2y equals 10. Divide by negative 2, you get y is negative 5. And there you go. There's your x and y intercepts. And there's your standard form. Now, let's look at the next one. X equals negative 3. Well, you're obviously not going to change this one into ax plus by equals c. There's not even enough stuff to do that. So what you have to ask yourself is, what type of line is this? Well, this is a vertical line. Anytime it just says x equals, that's a vertical line. If we were to just draw a real kind of rough sketch here, x equals negative 3, 1, 2, 3, would look something like this. So obviously the x-intercept, say x equals negative 3 is, well, negative 3. What's the y-intercept then? Well, it never crosses the y-intercept or the y-axis, so it doesn't have one. So the third one here is the exact opposite situation, where again, if we look at a graph real quick, y equals 4, 1, 2, 3, 4. This is a horizontal line. Well, a horizontal line obviously doesn't have an x-intercept, but it does have a y-intercept, and it crosses at 4. Okay, hopefully that makes sense so far. Let's move on though. Let's talk about this example here. Let's just see what we remember. Okay, find the slope. Okay, so we can use our slope formula that we wrote down a few moments ago. So I would do 12 minus 9, okay, over 3 minus negative 5. 12 minus 9 is 3. 3 minus negative 5 is actually 8, so my slope is 3/8. Okay, but what about this one? Okay, I want to know what's x. Okay, if a is 4, comma x, and b is negative 5, 1, and my slope equals, let's say, 2. Okay, so I know my slope this time, but this time I want to know what is this x-coordinate have to be, okay, in order for us to have slope of 2. Well, what I'm going to do is I'm going to still set up my slope formula. I know that in order to do this, I'm going to do 1 minus x is equal to negative 5 minus 4. And that's going to be equal to my slope, which is 2. Well, how do I solve that? Well, I would just solve it if I just make that a proportion. Okay, I'm going to simplify this down here real quick. So let me just move over. 1 minus x equals negative 9. I would cross multiply. So I get 1 minus x equals negative 18. I would subtract 1. So I'd get negative x equals negative 19, or x would have to be 19. So this would have to be at 4 comma 19, and this would be negative 5, 1, and if we drew the line between them, the slope would be 2. Okay? Okay, so let's move on to the last thing we're going to talk about. Okay, and that's parallel and perpendicular lines. Now, parallel lines, as you know, they don't cross. Okay, and they have the same slope, but they'd have different y-intercepts. Now, they have to have different y-intercepts because if they didn't have different y-intercepts, then they would actually be the exact same line. They'd have the same slope and same y-intercept. So that wouldn't make sense. Perpendicular lines, have what we call opposite reciprocal slopes, which we'll talk about in just a moment. Okay, so example we have down here, it says write the equation of a line given the following information. Okay, equation of a line that goes through these 2 points. Okay, now we're not talking about parallel and perpendicular yet. We will in just a moment. Okay, but let's think about it. How do I go about writing the equation given these 2 points? Well, you do have something that's called point-slope formula.